Okay, so number 14 on page 571. Find the de Broglie wavelength of a deuteron of mass 3.3 times 10 to the negative 27 kilograms, moving with the speed of 2.5 times 10 to the fourth meters per second. So you're looking for lambda, and lambda is equal to h over mv. So 6.626 times 10 to the negative 34 joules seconds divided by, they gave us the mass, 3.3 times 10 to the negative 27 kilograms, and the velocity 2.5 times 10 to the fourth meters per second. When you type this carefully into your calculator, you should get 8.0315 times 10 to the negative 12 meters. Okay, number 15. What is the de Broglie wavelength? So again, you're looking for lambda. It's equal to h over mv. H is 6.626 to the negative 34 joules seconds. So what is the de Broglie wavelength of a proton moving with the speed of 1 times 10 to the 6 meters per second? Mass of the proton, 1.67 times 10 to the negative 27. We know the mass of the proton is really 1.673 times 10 to the negative 27. If you didn't use the 3, don't stress, our numbers will be almost the same. But since I always tell you it's 3, I'm going to use 3. Times 10 to the 6, 1 to the 10 to the 6 is the speed. When you do the math, you should get a wavelength of 3.961 times 10 to the negative 31 meters. Notice how much smaller this is, in part because the I was thinking then of the electron we did in class. It was to the 10th, and this is to the 31, but it's because the mass is significantly bigger. And the larger the mass, the smaller the wavelength's going to be, assuming that the speeds are close to the same. Number 16. An electron is accelerated across a potential difference, so V is equal to 54 volts. Find the maximum velocity of the electron. So they're changing it up a little bit here on you. But remember that V is equal to EK max over Q. And so you can either find your EK max and then your velocity, or you can say, oh, but that means V is equal to 1/2 mv squared over Q. So QV equals 1/2 mv squared. So V squared, speed V squared, is equal to 2Q times voltage over M. So what was this? An electron, 1.602 to the negative 19 coulombs. Voltage, they told us, was 54 volts, and the mass of an electron, 9.109 times 10 to the negative 31 kilograms. Remember, this is V squared. You're going to have to take the square root. And when you do, you should get 4.3582 times 10 to the 6th meters per second. So that's after you've taken the square root. Final answer. Number 17. A neutron is held in a trap with a kinetic energy of only 0.025 electron volts. So EK is equal to 0.025 electron volts. What is the velocity of the neutron? So we know that, did I miss a part B? I did. Sorry, in 16 there's a part B. It was only when I wrote part A for that one. Part B is calculate the de Broglie wavelength. So lambda is equal to h over mv. So 6.626 to the negative 34 joules seconds. It was an electron, so 9.109 to the negative 31 kilograms, and the speed is the 4.3582 to the 6th that we just found. And you should get a wavelength of 1.669 times 10 to the negative 10 meters. for our little electron dude. Okay, sorry about that. So, like I was saying, 17a, what is the velocity? So remember again, Ek max, but Ek is equal to 1/2 mv squared. So v squared is equal to 2Ek over m. So 2 times 0.025 electron volts, but it needs to be in joules, so you need to multiply by 1.602 to the negative 19 joules per electron volt. And then this is a neutron, and the mass of a neutron is 1.675 times 10 to the negative 27. Interesting, they told you the mass of the proton, but not the mass of the neutron. Remember again, this is v squared, so after you get your answer, you do need to take the square root, and you get 2.1868 times 10 to the third meters per second for the velocity of the neutron. What is the de Broglie wavelength of the neutron? So lambda equals h over mv. So 6.626 times 10 to the negative 34 joules seconds divided by 1.675 to the negative 27 kilograms, 2.1868 to the third meters per second. And you should get a wavelength of 1.809 times 10, lost it, times 10 to the negative 10 meters. 17, yeah, I'm just making sure I was reading my right answer off there. Okay, that's 17. 18 says kinetic energy of a hydrogen atom electron is 13.65. So again, Ek 13.65 electron volts. Find the velocity. So exactly what we did up top. Ek is equal to 1/2 mv squared. So v squared is equal to 2Ek over m. So 2 times 13.65 electron volts, which you have to switch to joules, 1.602 to the negative 19 joules per electron volt, and then divided by the mass of an electron, 9.109 times 10 to the negative 31 kilograms. Again, remember that's v squared. You need to take the square root, and when you do, you get 2.191 times 10 to the 6th meters per second. And that is 18a. B says calculate the de Broglie wavelength of this electron. So lambda equals h over mv. 6.626 times 10 to the negative 34 joule seconds. 9.109 times 10 to the negative 31 kilograms times 2.191 times 10 to the 6 meters per second. And you get a de Broglie wavelength of 3.3197 times 10 to the negative 10 meters. Now part C, I don't suspect you'll, okay, C says compare your answer with the radius, they give it to you, the radius of a hydrogen atom. So the radius of a hydrogen atom, they tell you, is 5.19 nanometers. So 5.19 times 10 to the negative 9 meters. This is times 10 to the negative 10. So if you want to compare, you could do a ratio. So you could do the radius divided by, maybe the other way around to make it bigger. Lambda divided by r. And what you get is something close to 1/16th, right? If you divide lambda into r, I think you get 16. Let's see, 5.19 to the negative 9 divided by 3.3197 to the negative 10. And you get 15.6. So it's about r to lambda